Systems of equations, systems review problems. We're just going to solve these two systems. So in this one, I see that x is isolated on one side of the equal sign, and in this one, nothing is isolated. Well, whenever we have a variable that is isolated, that means that we can substitute what that variable equals into the other equation replacing the variable. So in this situation, we'll take this equation right here, and we're going to write it out, but instead of x, we're going to replace it with negative y minus 1. So we'll have negative 18y is equal to negative 108 minus 3 times the quantity negative y minus 1. And so our first step here can be to distribute that negative 3. So we'll have negative 18y is equal to negative 108. And then negative 3 times a negative y is plus 3y. Negative 3 times negative 1 is plus 3. Now we can combine the negative 108 with the 3. So we have negative 18y is equal to negative 105 plus 3y. All right, now I need to start undoing operations. I'm going to get all of my x terms or my y terms on one side by subtracting 3y here. And when I do that, I will have negative 21y equals negative 105. And now I have negative 21 times y, so I need to isolate my y by dividing by negative 21. And when I do that, I get y is equal to 5. All right, so let's see how much room we have on the page here. Oh, nice, plenty of room. Good, good. So now we need to solve for x, and I can use either one of my two equations and plug 5 in for x. Well, x is already isolated here, so that's the equation I'm going to use. So I'm going to kind of make it my blue equation, and I'm going to bring it down here, and I'm going to have x equals negative, but y is equal to 5. We've got that right here, so I plug it in for the y, and then minus 1. Well, negative 5 minus 1 is negative 6. So our solution to this system of equations is the point negative 6, 5. And we can check our work by plugging that solution into the two original equations. And I am not going to do that right now because I don't want the video to get too long. But what that would look like is this. So it's negative 6, 5. So if I plug in negative 6, 5, I can see that this is negative 6, and it equals negative 6. And here, if I plug in negative 6 and 5, well, I don't know, I see this side is plus 18, so this is going to be negative 90. And on the other side, negative 18 times 5 is also negative 90. All right, that was a quick one. Quick check. So if you didn't catch what I did, pause it, go back and have a look. Here, we have two equations that are both written in standard form. Almost always when we have something like that, it's going to be the best thing to do is the elimination method instead of the substitution method. Unfortunately, I have 8x and 3x, so there's nothing easy to add or subtract there or multiply. Like I can't just multiply by something to eliminate. And I have negative 2y and positive 3y, nothing easy there either. So here what I'm going to do is I'm going to take this 2 and the 3, and I'm going to take my equation. So I'm going to take this equation, and I'm going to multiply by, I'm going to multiply by the 3 So multiply by 3, and that comes from this right here. I've decided to eliminate the y's, so I will get 24x minus 6y equals 18. I've just multiplied every part of this equation by 3. Now I'm going to take the other equation and I'm going to multiply it by the 2. So I will get 6x plus 6y equals 12. And so I decided that I was going to eliminate the y values. So I chose the coefficient in front of each of the y values. I multiplied this equation by this coefficient. I multiplied this equation by this coefficient. And look, now my y's are set up to be eliminated nicely. So I'm going to add these together because when I do, I will get a 0y. Sometimes you subtract, sometimes you add. I get 30x plus 0y is equal to 30. So here's the 30x equals 30. Now I can divide by 30 and I'll get x equals 1. I've solved for x, I need to solve for y. I can use either of the equations that I want. I am going to use this equation right here. So I have 3 times 1, so I'm just replacing the x here with the 1. 3 times 1 plus 3y equals 6. Now notice I didn't use my multiplied equations. I used the original one. And that's usually the way we do it. We could use one of those, but we generally do not. So this 3 times 1, that's 3, plus 3y equals 6. Now I can subtract 3 from both sides. I get 3y equals 3. And next, I will divide by 3, and I will get y equals 1. So my solution to this system of equations is the x value was 1, the y value was also 1, and that is my solution. And those are a couple systems of review problems.